Hello guys, this is Vrat Soni and welcome to the another video of machine learning and artificial intelligence on this channel. Today I'm gonna talk about some deep learning and I'm gonna talk about assignment that I got and how I did to complete that assignment. So let's get going. So for first of all, I used Google Colab to complete this assignment, and this is a kind of a deep learning assignment that I got. So first of all, let's read some instructions. It says fashion MNIST. It's a data set and it's an alternative data set of MNIST, so it's not a very big deal. And another default data set that we can access through Keras. Keras is a library which is used for deep learning. So let's get going. First of all, we have to load this dataset. So of course, to load the Keras dataset, we have to import this library from keras.datasets, import fashion MNIST, and I have used matplotlib again in this video to plot some graphs and some handwritten images. So I'm gonna run through this one more time. So it is completely perfect. So in order to load this data set, I have created variables which are called train images, train labels, test images and test labels, and this is a fashion MNIST dot load data as a part of this code. So I loaded this data set perfectly, and we can use this data set whatever we want to do with that to perform some operations. So first of all, these are the questions that I got in order to complete this, and in order to get to acquire a knowledge regarding deep learning. So it says, what are the dimensions of train images, train labels, test images and test labels? So first of all, in order to get the dimensions of any kind of data set, you have to use a shape method which will give you a dimensions. So I'm gonna run through this one more time. If I'm commenting this thing, so it will run train images dot shape. So we have 60,000 comma 28 into 28. It's a 28 into 28. It's a that dimension. And if I'm gonna run through these labels, so it will say 60,000 labels as well. So it is a kind of a data set which we are going through in this video. So let's get started. It is working perfectly fine. I'm uncommenting this all. There we go. So now the second question is, what are the lengths of a train labels and test labels? So we all know that to in order to find the length of any kind of any label in dataset, we have to use length as a method, and I use the same thing, length as a method in both of this thing, and I'm running it again. It is working perfectly fine. Moving towards the next question, it says, please show some of the train and test labels. So I used directly train labels and test labels in order to find this array to show some content. Now moving towards the next question, it says, please show the digital content of a image of index 5 in the training data set. Now I want to pass the index as a 5 in the training data set. So I took training images and in bracket I said 5 in order to access the fifth index of this data set, and I got this as an array, which is pretty cool, right? Now let's move towards the another question. It says, plot the image of index 5 in the training data set. So I used PLT as a library, and I used this method in order to take these parameters, train images of fifth index, and CMap as a function for the binary, and I use this plt.show to show this image, and it is working perfectly fine for me. You can try it on your side as well. What is the label for the index 5 in the train label, and looking up in the above list, what does it mean? So the label for the index 5 in the training label, it is 2. So I access this element as this, and Now moving towards the next question, it says please show the digital content of image index 500 in the testing dataset. Now we have to do the same things as I mentioned above. I used this test image instead of training, which I used earlier, to in order to take the 500th index, and this what I got. It is pretty cool as well. Now in order to plot this, I used this as a library which I used before. It is nothing change in this, so I'm not gonna explain it again. Now moving towards the next question, it says what is the label for the index 500 again. it I have used this to access this element. Looking above up in the list, what does it mean? It's a pullover. I mean, it means a pullover. Now, 10th question says, please import the models and layers from the Keras library. I find this thing pretty cool about deep learning, that it has the models and layer in the Keras library, and how to import this. So I used from Keras import models, and from Keras import layers. I used this, which is pretty cool. Now moving towards the next question, it says define a sequential model and call it my network. So I created my network as a variable, and I declared a dot sequential as a model. It is a kind of a function or property, you can say, of in models. So it is working perfectly fine on my end. You can try it on your own. Next thing is reshape the images from 28 into 28 to one column with 784 neurons. Now, okay, so I used this reshape to reshape the images, which is 60,000 images, and 28 into 10, 28, its dimensions, which is 784, but I write 28 into 28. And for test images, I use the reshape property, same here, but it has 10,000 images and 28 into 28 dimensions, which is working perfectly fine for me. And I use this train images.shape just to see how it is working. So it is working perfectly fine on my end, so I'm gonna comment this out. It's just for my consideration. Now, in order to flatten this thing, use two methods from the book. So I used one from the book, and now I'm gonna use again from that 20-minute video. So in order to flatten this thing, I have to use the I had to use the TensorFlow as a library. So I import this thing over here. I made a model same as I did in the models.sequential, and then I flattened this thing out, which is working perfectly fine for me. And now in order to check how it is working, so over here it has a length of array. So in order to do it in a single column, I used this as a reshape, and this result what I get in a very cool manner, just one column of each, not the whole array. I got this one as a result, which is working perfectly fine. Now moving towards the next question, please normalize the image by dividing the image by 220 255. Again, it says to use two methods, one from the book and one from the video. So to normalize the method, we have a pretty cool function, which is s type float 32 by 255. I used in train and test images. And the second method I used to normalize this thing is from Keras dot utils dot normalize, and I use this train and test images in the parameter, and axis is equal to 1. So let's try this out. It is working perfectly cool. You know what, I can try this as well. I'm gonna comment this out, and if I'm trying this on my side, it will run. So it is running perfectly fine with zero errors. So I'm gonna comment this out again, and I'm gonna leave this uncomment just for my satisfaction. I type this thing to see how what result I will get. Now the 14th question is add one layer, hidden layer, that has 512 neurons. using ReLU activation function. Now, in order to apply hidden layer in any deep learning, we have to use dense as a function in layers. So what I did is I did my network dot add, then in brackets layers dot dense. Oh, sorry, it's from up. Layers dot dense, which is same thing, and 512, which is neurons. I passed the parameter activation function as ReLU, and I input shape is 28 into 28, which is not a big deal. We can write this, it's our personal choice, but I use this as a function and it is working perfectly fine for me. But over here in 15th I didn't write this input shape, though it is working perfectly fine for me. So just I did two different methods of this thing. It is the same thing, just it has a 512 networks over here, 128 neurons over here, and I use this input shape over here, which is mentioned in book, and I neglect this thing over here because it is the same thing. So it is the different way of writing the same thing. Now moving towards the next question, add the last layer as a 10 neuron dense layer that uses softmax as an activation function. Now softmax is an activation function such same as ReLU, but why we use this for the last layer and how does it work under the hood? So first of all, how to add the last layer of 10 neuron base, I mean 10 neuron dense layer. So in order to add that, I use the similar function as mentioned above, layer dot dense and 10 as activation at 10 neuron, which is replaced by this, and activation equal to softmax function. And now why I use this, so I have made an explanation that we use softmax for the last layer of our network because it converts the output of the last layer into your neural network into what is essentially a probability distribution. Now I made this a bit simple over here. To make it simple, it gives us the probability answers for classification rather than margin score. So what it does is it is not giving us a margin score, rather than that it is giving us a probability, that what probability we are gonna get in the classification problems. Here it says classification, I misspelled that. There we go. So it is working perfectly fine for me. Now 17th, so this is a pretty cool function. Use the following two settings for the compiler and run them separately, see what the differences are. So first of all, I'm gonna show you what are these functions. And so first of all, this is an optimizer function. Now to compile this thing, I used the compile as a function and optimizer Adam I used, and the loss I use sparse categorical cross entropy, and matrix is equal to accuracy. I did the same thing for the next one too, but in place of Adam I use RMS prop, and everything is same rather than this. Other than this, it is a sparse categorical constrophe, but in order to get this I used categorical constrophe, which is mentioned over here. So these are the two different functions which I am trying to get. Now in order to run them separately, I used TensorFlow library again, and I import two categorical. Now train labels equal to two categorical train labels and test labels two categorical test labels in order to run this function. Now let me see, it is working perfectly fine. I can run this as well, I can run this as well, but I comment this because we cannot use both the functions both the functions at the same time. So I used this as a function, and now at the end what we need to do is to fit the model and to find the pattern. Now after the compilation, please try to find the pattern using a fit command. Epochs need to be 10 for this example. So in this example they have mentioned 10 as an epoch. So what I did is I used fit as a function from my network, which I mentioned earlier, and I used train images as a parameter, train labels. I'm gonna train this on my I'm gonna train my model on this, and I used epochs equal to 10 and I made batch size equal to 128. So what it's gonna do, it's iterating through a loop. Let me show you. So batch size 1 out of 10, so it is working in batches and it's gonna iterate the loop at the same time. So it's gonna take a couple of seconds to run through this. Till then we can read the next question. It says, how do you compare the fashion amnist with what we have learned in the class using the amnist? Now, honestly speaking, fashion amnist and amnist both are the same data set. It's the fashion amnist. It's just an alternative data set of amnist, which has 60,000 same images and 10,000 same test images, same labels as well. So there is no difference between that two. So that's the thing. See, it is working perfectly fine for me. Now I write this the same thing over here, that train test examples are the same with 10 classes, which is 10 different classes of fashion and clothing, and 28 into 10 28 into 28 dimensions of grayscale images we have in that data set. So there is no much difference between them. Now moving towards the next question. It says use the evaluate to calculate the achieve accuracy. Now, in order to calculate the achieve accuracy, we have to use evaluate as a function. They have pretty good function in deep learning. So I used this variable result is equal to my network dot evaluate test images and test labels, just to see the how accurate my model is. So I'm gonna try to run it, and now I used the other function. Now it says 64% and 75 function, which is good. It was working perfectly fine for me before with 75% accuracy. See, and now it is not working perfectly fine because what my model did is my model overfit my training data set. Now there is a term called overfitting which is used in our area just to how can I explain, my model fit the trained data set as per their data, and now it is not working perfect on my test data set because it had seen my training data set before and it was working according to them. So this what overfitting means. So in the next question it says, do we have an overfitting? Yes, we do have, because the perform accuracy is lower in the test data set, see, compared to the training. So my model overfitted, which is not pretty cool, but yeah, that is. So this is the end of this video and what I got for my assignment. Thank you for watching this video and have a great day.